Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. Welcome back. Thanks for watching this video. So today we are in the midst of looking at logic gates, truth tables, and Boolean expressions. And our particular topic today is taking a gate diagram and making a Boolean expression from it. So let's get started. So we'll call this gate diagram to Boolean expression. So let's start out with drawing ourselves a gate diagram. So in this case we've got X, Y, and Z, and it's helpful to make the sound effects for yourself. Boom. Adds a ch and a boom. Yeah. How exciting. Look at that. Very exciting. Okay, so now we are going to make this into an SOP form. So I got AND gates that feed into an OR gate and then out. And this will be function F1. So let's see what we have. Big reveal here. So let's go with, we'll go this. Oops, sorry about that touch there, but we're going to leave it and do that. And okay, and then we'll do this and that. Okay. So, how do we go about doing this? Well, what we're going to use is a technique called propagation of variables through the gate network, and it's pretty nice to do. So I'm just going to switch my color here, and we'll just go ahead and work through it. So first off, we have X. For every gate, we can write down what comes out of the gate, and so X is incident on this gate, and what comes out of the gate is X bar. And what comes out of this gate here is Y bar, and what comes out of this gate here is Z bar. Okay. So then we can follow those to the next gates, and I like to put the inputs on the input side and the outputs on the output side. And so we have X bar and Z bar both coming into this AND gate. And so then the AND operation is performed on X bar and Z bar, and what comes out of the gate is X bar. Oops. I'm just gonna write a. Oh no. That means I have to go back to my black. You really should learn how to use these tools. So to the blue. Alright, so we got X bar and Z bar coming out. So what I'm doing is just writing the part of the Boolean expression that is in the middle of the logic diagram. So I look at the inputs that come into that gate, and I write the outputs on the other side of the gate. And we do that for all the gates. And so in this one we have Y coming in, and we also have Z coming in. And so the output to the AND gate here is just Y, Z. And now we have these inputs, our X bar, Z bar, and Y, Z going into an OR gate, which gives us our final expression is X bar, Z bar, or Y, Z. And that's how easy it is. So not too difficult, just kind of propagate those variables along through the gate network to get our final expression. Let's do one more example. All right, already getting better at this. Okay, so in this example, we will go ahead and draw our gate network. I'm going to do this a little bit differently. So we have our, this time, OR gates feeding in to an AND gate. To generate F2. So notice that I'm writing this with the intention of kind of understanding that this is a POS form, because we have our sum terms right here with the OR gates feeding into a product term here with the AND gate. Okay. All right, so this is how I'm going to do it differently. I'm going to not use this vertical structure that we've been using here and just kind of create it as we go along. So first off, I'm going to have A, and A is going to enter into that OR gate there. And then we're going to have B, and I'm going to invert B. That's going to enter right there. And then we have A bar, and so I'm going to make a bar going into here, come from A, okay? And then we're going to have B, so I can take from B right here. And then we have C, so C right there. Okay, so a little bit different in terms of how we built this. So when you have small diagrams, sometimes it's helpful to do it in this fashion because you're not grabbing from those lines in a bunch of different places. But as you get into larger diagrams, having that vertical structure for your inputs is beneficial. So I just wanted to kind of talk about that. All right, so let's go ahead and mark the outputs of all the gates and inputs where it makes sense. So this is far away from A here, so I'm going to mark this as A. And then we have B coming into this inverter gate, so this is B bar, which then moves up to here, and that's also B bar. And then we go through an OR gate, so this is going to be A or B bar, okay? Or if you want to say this another way, it could be A or Barbie, or A Barbie, okay? So, now we have the other side. We got A into an inverter right here. So this is going to be A bar. And then we have B. I'm just going to copy it over here since it was kind of far away. And then C. So we got A bar, B, C, all OR together. So we got A bar or B or C. And now these are entering into this AND gate, which goes to our function. So we can then write this out as our function, and there it is. So I find this method to be quite straightforward and quite easy to implement, and I hope you do too. So I hope this had value for you. I'm Mike Stancic. This is Digital Electronics Classroom, and thanks for watching. Have a great day.